Brilliant. Okay, so today let's have a recap of the terminology and we'll talk about overriding today. So the big thing of this topic is we have different programming paradigms, different ways of solving a problem. It's not that one solution is better, it's just you have different approaches and some are better in different scenarios. You're perhaps used to procedural, where you have procedures and functions. We haven't covered assembly yet, but I'm looking forward to doing that. So assembly is a low-level language. We're interested in high-level programming languages. And object-oriented code is a feature of certain high-level programming languages. High-level does not mean difficult. I would say that the low-level stuff is perhaps harder, but you could argue that they're easier. They're just different. So little man computer will come back to, addressing modes will come back to. We're focusing on object orientation, the way of seeing the world through objects and classes, a more human way of approaching problem solving. And we talked about a class being a template to allow you to create instances of that class, which are objects. And we talked about inheritance, so that you can have the behavior and the data storage requirements of one class determined by, inherited from, a parent class, a base class. You can also call that a superclass. And then the opposite is like a subclass. Think of you like being sub, as in slightly slower, slightly less than your parents. Your parents are slightly more super than you. And then at some point in the future, you'll be slightly more super than your children, and your children will be slightly sub you. A derived class is just another way of saying a subclass. You derive two things. You derive your functionality, your methods, and your data storage requirements, your attributes, from your base class or your superclass. And then last lesson we talked about instantiation, which is just saying I would like a new object. What is a new object? It's a new instance of a class. So we made a constructor. A constructor could be an empty constructor, no parameters, or you can throw data into it. The point is the return value of your constructor is a new instance of that class. So today we're going to override behavior. So what happens basically when you have some behavior that you inherit that is different? So I don't know, a fish might move differently to an animal, or a mammal might move differently to an animal. So how can we override default behavior? Let's make a new project. I'd like it to be a C# console.NET framework. And we will call it food OOP this time, food OOP. I'm saving it on the C drive because I'm doing it on my laptop, but you should make sure it's in your W drive folder, please. So we're going to make a class called food. And what can you do with food? Well, you can eat it, thankfully. Life would be a lot more boring if we couldn't eat food. And then we're going to have different types of food, like veggie food and halal food, all sorts of different things. So make sure that your class is defined. Usually it's defined in a different file. So we should probably start doing that, really. Shift-Alt-Enter to go out of full screen. Come on. Super slow. And we'll make a new class this time. So right-click on your project and add a new class. So you can define classes in the same file, but it makes it more modular, more reusable if they're in different files, because then you can just copy and paste the files into a different project. So I would like this food class to be called food. It will automatically append that with .cs for .C#. So we've got a new file. Notice that this class food is in the same namespace. So the project is a namespace, like a global scope. So things defined in this namespace can access each other. So back in program, we're in namespace food OOP, and then food class is also inside that same namespace. Right, so I would like a method to be able to eat this food. So hopefully when you eat, normally, unlike my 5-year-old this morning, when you eat, nothing comes back. There's no return value. So it should be void. Eat. And we need to know what we're eating, but I guess we're eating just the food. So let's put a message in here so that we know what's happening. Console.writeLine Yum. So we should probably define some attributes as well as some methods. This is a method because it's some behavior. We make an attribute, then we should probably say what it's called. So what is the food? So let's have a string called variety, I suppose. And then we can say you just ate a, well, maybe we should have quantity as well, shouldn't we? So let's just pretend it's an integer to keep it simple for now. Quantity. And then let's display that. So if, say for example, variety is going to be like apple and quantity is going to be 3, then hopefully it should display something like here. It might not necessarily have an S in the right place, but it should at least work. Okay, so let's make a new instance of that class. I'm going to do this with comments and then pause the video and let you do it. So make a new instance, help, my computer has frozen, of the food class called fruit. And we need to set the quantity to 10, set the variety to apple. I'm going to pause the video. You should do that if you're watching at home. The first thing that we need to change is make the things we need to access public. So we need to make eat public. And if we want to be able to change variety and quantity from another class, it needs to be public. So we will come back to this later when we talk about encapsulation, because it's not usually a good idea to leave everything public because everybody can see your public information and change public information. So it's better to keep it private. But for now, I haven't shown you how to encapsulate it. We'll come back to that later. Okay, so we now need to make a new instance of the food class. So we have the name of the class, the name of the instance, fruit, and then the new keyword, and then the name of the class again to call the constructor. And we only have the default constructor with no parameters. So if we want to set the quantity to 10 and the variety to apple, we have to do that ourselves at the moment. So fruit.variety is going to be apple, and fruit dot, I don't know, what do I need to change quantity, is equal to 10. Okay, so your next job, and I'll pause the video in a moment once I've explained it, is this is messy. I don't want to have to change the attributes all in one go. I would like to be able to set the variety and the quantity in the constructor. So we need to define our own custom constructor. I'll pause the video. That's the next thing that you should work through. In order to make this work, we need to have a constructor. So public, because we want to be able to access it from outside the class. The constructor's name is always the same name as the class. Then we can define some parameters. The parameters that I'd like are the variety and the quantity. So that should get rid of the syntax errors when Visual Studio catches up, because we're passing in the variety as a parameter, we're passing in the quantity as a parameter, but we need to do something with it so it's remembered, it's stored. So in order to do that, we need to access this variety and set it to this variety. Notice I've deliberately used the same names. At GCSE level, Edexcel always likes to prefix a parameter with a P to avoid any confusion, but I think that's bad practice, because I think it's better to understand the difference and be able to use them differently. So how do we do that? I'm going to say the variety that belongs to this particular food, so the current instance of the food class, this attribute here, that is going to be set to the variety that we pass in as a parameter. So this dot quantity equals quantity. So if you just use the name of a variable, it will first of all try and find it as a local variable or a parameter, and then it will try and find it as a an attribute. Okay, so the next thing that we're going to do is just display that fruit. So we're going to do console.writeLine and then fruit. And then when we run it, you might expect it to say you've just eaten 10 apples, but it won't. It will say something different. Pause the video, see if you can work out what and why. So what I'd like it to do is do something like fruit.eat, where it says you've just eaten 10 apple, rather than saying the name of the project and the name of the class. So in order to do that, we need to overwrite what's actually happening here. So behind the scenes, we're saying fruit is being displayed. And to display something, you need to convert it to a string first. So what we're actually doing is saying fruit.toString. We're converting it to a string and then displaying it. So how on earth do we convert a fruit to a string? Well, the only way that C# knows how to do this is to say the name of the project and the name of the class. But I don't want that behavior. We've inherited that from a base class called object, which is rather irritating because it's a class called object and it destroys the distinction between the two of them. So we want to override that behavior. So in our fruit class, we will public override, and then it will auto to complete if we press space. These are the default behaviors that we inherit. Even though we haven't said food inherits anything, it actually does inherit everything from the object class. And the object class allows us to do three things. It allows us to compare two things. We'll come back to hashes later in the spec. And we can convert things to a string. So I would like to convert this to a string. And instead of accessing the method from the base class, like we saw before, remember base just means parent, we can define our own behavior. And that's what we want instead. So let's define our own behavior that just says quantity of variety, as in 10 of apple, or 10 apples. So now we've overridden the default behavior of how to convert to a string, so that when we run it, we call our own behavior instead of the default behavior. And this is one of the many things that makes object-oriented code so powerful. I really want to show you the quick shortcut for putting an S on the end of it's over 1, but I'll leave that as a challenge for you because it's 20 past and we've run out of time.